Let's solve y prime of x equals x squared and y of 1 equals 2. So we'll do this by using integrals. I'm going to do a definite integral that goes from 1 up to x. And then here you put y prime of x and then ds. And then make this also ds. So let's stop for a second. Let's talk about this. ds, that's the differential. Notice has an s in it. S is what we call a dummy variable. Also now it's not y prime of x, but y prime of s. S again is a dummy variable. Why do we need 1? Because we're using x as the upper limit of integration. That's why. The 1 on the bottom that you see here, that's because this is 1 right here in this position where it's red. You see that's 1. So you put that also 1 on the bottom, and the x is the upper limit of integration. Okay, on the right side, we're going to do a definite integral again from 1 up to x. And just integrate the x squared. So, but now it's going to be s squared ds again, because we're using a dummy variable s, and the upper limit of integration is x and the lower is 1 because this is 1 right here. The 2 that you see here for now is not incorporated just yet, but it will be eventually. So on the left side, how do you integrate that? Well, all you can really write is y of s this way. Why? Because the derivative of y of s is y prime of s, and the integrand is the derivative. So it's y of s, and then this is x, and this is 1. So those are the limits. And on the right side, you can actually do the integration. So it's going to be s cubed over 3 by the power rule, like this. So let's do it this way. So s cubed over 3, and then up here you put in the limits. So the limit on the upper end is x, and the lower limit is 1 this way. So notice that I'm incorporating the limits, and by using limits like this, a definite integral, you can incorporate an initial condition directly into the solution of your differential equation. So now you plug in, you're going to have y of x, and stop for a second. I'm just replacing s with x, and notice this is what we are looking for. We're looking for y of x equals something else. And this is now minus y of 1, and stop for a second. Notice that y of 1, we have that. It's right here. It's equal to 2, you see? And on the right side, what you have is x cubed over 3, and then you're going to have minus 1 cubed over 3, which is just 1/3. And then you're going to have y of x is equal to x cubed over 3, minus 1/3, and then it's going to be plus y of 1, taking that over to the right to addition, but y of 1 is equal to 2, so you're going to put a 2 here. And then you're going to have y of x is equal to x cubed, so minus 1/3, and then, okay, so multiply 2 by 3 gets 6/3, like this. So that means we have y of x is equal to x cubed over 3, and then let's see, so plus 5/3. Is this okay? Well, you can just graph it and check it from there. So let's graph y cubed over 3 plus 5/3. When you do that, so we want the y of 1 to be equal to 2. That's the only condition we have. So we have the point 1 comma 2 on the graph. So y of 1 is right there, isn't it? You see? So when 1 goes in, 2 really does come out. So the point 1 comma 2 is part of the graph. So that means that x cubed over 3 plus 5/3 is basically the solution through the point that looks like 1 comma 2. Notice that here in this result, right, kind of important, right, there is no c is present. When I say that, what I mean is no c is present like as a letter. Okay, that's gone. There's no c or a or whatever, the constant. The constant, the entire integration process produces the final function that you need that goes directly to this point, and all of that comes from having the definite limits of integration set up on both sides. I'll leave it at that. So if it's helpful and all that, leave a like. I'll see you in another video.